Thanks for that generous introduction. And I'm really happy to be here because I have a real special interest in younger people with this disease because they are the big losers in losing their life, their quality, their features, etc. So it's one thing for my old timers who've been sick 25 years and we struggle along and things like that, but it's really a joy to see Jennifer doing better and ending up back in society and having a semblance of a normal life. I want to, rather than go into the disease and what we know about it and things like that that would probably make you all fall asleep, I would like to present how medical research happens now in the United States as it applies to an enigma like chronic fatigue syndrome, which is one of the most interesting multi-system diseases that we're faced with. And that's one of the reasons I went the route of a private foundation, because the government, the CDC, and the NIH have really failed us in this area. And the reason is multifactorial. There's political problems, there are large bureaucracies, and they haven't been properly funded for the last 10 years. So there's multiple reasons why they have not been particularly effective. You hear the terms translational medicine, and translational medicine is supposed to mean the researchers talk to the clinicians, talk to the patients. But in reality, it's much more difficult to make that happen than it sounds on paper. So translational medicine is a buzzword these days. It's supposed to yield productive, cheap medicine, but it's hard to execute, I can tell you that. The other term I want you to focus on is collaboration, because obviously in this time, with internet and instant access to everything, doctors shouldn't be doing things in isolation. They should be collaborating with the best researchers and the drug companies, etc. However, there's stumbling blocks to making that work as well, and I'll outline some of those things for you. So, as I sort of got older and been in this in 25 years and sort of frustrated, there's now 4 million people in the United States with this disease, of which 75% are disabled. It's a tremendous economic burden. It's estimated through the loss of work, etc., that the cost is about $30 billion a year for this disease alone, for loss of work, disability, nursing homes, institutionalizations, etc. So I've been in the field for 25 years looking for the etiology and pathogenesis of this disorder, and I think the state of the science is there now that we really do have clues. It's not this no man's land anymore. And a lot of that is because of the research that came about with the Human Genome Project, which was completed some years back, where we can look in a jiffy for RNA, DNA, protein, and you can explore almost any idea you have if you have the resources and the access to these kind of diagnostics. And I'll show you concrete examples of that. What we really know about this disease now is that it's a Neuro-Immune disease. It's a brain disease with inflammation in the brain mediated by cytokines, probably incited by a virus. Not one virus, but probably multiple viruses. And as we explore, that hypothesis is being found more and more true around the world by all researchers that are in this field. And one particular part of it is very intriguing to me, because the literature over the past 25 years has shown that these patients have low NK cell function. And natural killer cells are a real primitive part of our immune system. Sharks only have NK cells. It's the only part of their immune system that they have. So it's an ancient protective mechanism. And it scavenges for tumors and viruses. So when we found these people had very, very low NK cell function, sometimes 1 or 2% of normal, it now appears obvious why they develop tumors and viral infections. So the search is on to figure out why that is and what we can do about NK cells. So our vision is to see it as a treatable disease. 25 years ago, HIV was dismal. It was a death sentence. And you all know it's pretty trivial now. You take your drugs and see your doctor once a year and try not to spread it to others, and It's a treatable disease. You don't read about it in the paper anymore. They're still looking for a vaccine, but it's entered from this horror story to a treatable disease. So that's really what Symptom research is about as far as our vision. So our mission is to play a key role in this. All of us old-timers who are getting out there, where do we put our legacy? What do we do? You know, retire and the knowledge doesn't go on? So we think this, through collaboration, we can succeed in solving this problem. And the niche is in the pilot studies. And as Linda so nicely outlined to you, the big boys don't do pilot studies. They take them after the pilot data is there, and then they extrapolate it to multiple sites, et cetera, et cetera. A drug company is happy to come in after the fact, but drug companies will not do pilot studies because they see it as lost leaders, et cetera, et cetera. So that's our niche with research. And then I'm a big believer in collaboration, and I'll show that in a minute. I can't solve this by myself or my foundation or me doing a little drug trial. It has to be collaboration, and now collaboration means worldwide. It no longer means just the United States, the FDA, the CDC. So 25 years of work in this. I want to go to this point here because it's really the critical one for the project we're trying to get going. Since 1984, I've been freezing spinal fluid and serum on these patients for when the technology caught up. And in my biobank, we have now over 1,000 specimens that we can use without recontacting the patient or redrawing or doing anything like that. And for example, I have Jenny's spinal fluid and serum from when she was acutely ill. So with her permission, we can run it through the studies now. And it makes a very efficient, fast study. And that's another part that's very important in medical research these days. Here's our board of directors. Linda has graciously agreed to join us. And some of these people are here today. It's a broad spectrum of people representing law, the cloth, a physician, a patient. So they're helping me out with guiding us through what we should be doing. Our research approach again is to collaborate in pilot studies, which then launch you to R01s. But R01s are big 5-year grants funded by governments, the government of Australia, the US government, but you have to produce your pilot work first to be considered for an R01 grant. We're also associated with university research institutions, and of course the commercial biotech and pharmaceutical firms, they have lots of money, but they have to have a targeted project. You come to them with a specific virus that you want treated, and then you ask for their support in clinical trials. So we have a scientific advisory board, of course. Dr. Knox is here from Wisconsin Viral today, and she will be talking about her research. We have Sonia Marshall from Bond University, and you could say, what the heck is he doing with Bond University? Well, you're going to see in a moment, because they are the world experts in diseases that relate to natural killer cell dysfunction. So I established this collaboration because that's where I think the money is. And as Linda said, we might be wrong, but even a negative study is useful in a field like this. If we're wrong about this, we move on to something else. And we do have a research director that we are sharing with George Washington University because they have the expertise in conducting these kind of research trials. How do you do the grant writing and the execution and get it published and launch it on to drug companies, etc. These are the pilot studies that are already underway, and and here's our collaborators. Cytokines and chemokines are chemicals that signal from your brain to your immune system and back to your brain what's going on with you. And as an example, what makes you feel so sick when you get the flu is a cytokine storm. These chemicals are released, and that's why you get a fevers, chills, go to bed, etc. So one of the models for these people are they have the flu all the time. So if you want to think about how bad it is, think about you having the flu all the time. So, and why are we so interested in this? Because there's cytokine blockers now that are commercially available. So if we're right about our theory, we have a treatment. The difficulty is that what happens in the peripheral blood probably isn't where the action is, which is why I, for the first time, have proposed looking in the spinal fluid. And I have my repository of about 1,000 samples, so we can do this very, very quickly with the right resources.